Hello and welcome to the Biological Anthropology lecture series. I'm Dr. Richard Jonathan O. Tadurin. Here we explore what it means to be human, biologically, evolutionarily, and behaviorally. Let's begin our journey into the science of humanity. Welcome to Module 9, the genus Homo. Here, we trace the emergence of early Homo, the evolution of Homo erectus, and surprising new discoveries in our lineage. This is the point in the story where our ancestors begin to look and behave in ways that feel recognizably human, yet still carry echoes of the earlier Australopithecines. Let's revisit where we came from. In the previous two modules, we met small-bodied hominins experimenting with new diets, new landscapes, and a new way of moving. Now we shift into a chapter marked by bigger brains, more sophisticated tools, and the first steps beyond Africa. You might wonder why this matters. Think about this. Every major expansion in human history, from the first migrations to the technologies we rely on today, rests on biological and behavioral foundations that emerged during this period. As we move through this module, we'll look at Homo habilis, a species often described as the handy man because of its association with early stone tools. We'll explore how its anatomy reflects a creature still tied to earlier forms, but beginning to push the limits of cognition and adaptability. Then we'll follow Homo erectus as it becomes the first true global traveler, reshaping what it meant to be human through endurance walking, fire use, and remarkable persistence across continents. Recent discoveries, including Neanderthals, Homo naledi, and Homo floresiensis, remind us that human evolution was not a straight line, but a branching and overlapping story. Let's look at how these findings challenge long-held assumptions and enrich our understanding of our place in the past. In this section, we explore Homo habilis, its anatomy, adaptive strategies, and its place between Australopithecus and later Homo. Think of this species as standing at a crossroads in our evolutionary journey. It still carried many traits of its Australopithecine predecessors, yet it was beginning to experiment with new behaviors and body plans that would shape the future of our genus. Let's revisit where we left the Australopithecines. For more than 1 million years, these hominins thrived across eastern and southern Africa with their combination of bipedal locomotion, relatively small brains, and large, robust faces designed for heavy chewing. They were successful, adaptable creatures. But around 2.5 million years ago, something shifts. The environment becomes more variable, cooler and drier, and the once stable woodlands begin to break into patchier mosaics of grassland and open habitat. Think about this. When landscapes change, bodies and behaviors must adjust, and it's in this shifting ecological window that we begin to see the earliest members of Homo emerge. Let's look at what makes this transition so intriguing. In fossils attributed to Homo habilis, we notice a modest but meaningful increase in brain size, around 650 cubic centimeters on average. It's not dramatic compared to later species, but relative to Australopithecus, it signals a different trajectory. At the same time, the face becomes less projecting. The teeth, especially the molars, start to reduce, and the jaw becomes slimmer. These changes suggest a shift in dietary strategies, perhaps a move toward foods that required less heavy chewing but demanded more planning and tool use. You might wonder why a slightly larger brain matters if the rest of the body still looks so primitive. This is where behavior enters the picture. The appearance of Oldowan tools, simple but effective flakes and cores, shows that early Homo was exploring new ways of interacting with the environment. These tools allowed access to animal carcasses, increased dietary flexibility, and opened opportunities for scavenging that Australopithecines likely couldn't exploit as effectively. The archaeological and fossil evidence from sites like Oldowan Gorge tells us that these technological and anatomical shifts were unfolding together, creating a feedback loop between environmental challenges, cognitive demands, and bodily adaptation. At the same time, Homo habilis still carried many Australopithecine traits. The body proportions, short legs compared to the arms, tell us that it hadn't yet achieved the fully efficient long-distance walking of Homo erectus. In many ways, this species occupied an in-between space, retaining climbing abilities while gradually becoming more committed to life on the ground. Think of it as an evolutionary experiment, balancing old capacities with new opportunities. As we move forward, keep in mind that this transition was not about sudden breakthroughs. It was a gradual reorientation, brains enlarging slightly, tools becoming part of daily life, diets broadening, and landscapes opening. Together, these shifts set the foundation for the dramatic evolutionary story that follows. Let's revisit what we expect early members of Homo to look like. When students first hear the name Homo habilis, they often imagine a creature already close to modern humans, standing tall, walking efficiently, and using tools with a kind of early human grace. But when we look closely at the fossils, we see something far more complex and far more interesting. Homo habilis is a mosaic, part Australopithecine, part emerging Homo, and entirely shaped by the ecological pressures of its time. Let's look at the body proportions. One of the most striking features is the relatively short legs compared to the arms. This tells us immediately that Homo habilis had not yet adopted the long-legged stride that later becomes a hallmark of our genus. Its locomotion would have been bipedal, but not in the fully efficient, energy-saving way that Homo erectus mastered. You might wonder why this matters. Think about walking long distances across open habitats. Longer legs reduce the cost of locomotion, making endurance travel possible. Shorter legs, like those of Homo habilis, suggest a creature still navigating a mixed world, part ground, part trees, with a gait less optimized for roaming far from home. Even with these primitive proportions, the lower limb still shows clear commitment to bipedalism. The foot structure, pelvis shape, and knee joint all support upright walking. What we see is not hesitation, but gradual refinement. The species is moving confidently in the direction of human-like locomotion, just not quite there yet. The upper limbs tell another part of the story. The arms retain Australopithecine robustness, hinting at continued climbing, or at least the ability to navigate vertical space when needed. This doesn't necessarily mean Homo habilis spent large amounts of time in trees, but it does suggest that maintaining some degree of climbing capability was advantageous in the environments it inhabited. Imagine navigating a landscape that alternates between open ground and patches of woodland. Being able to climb for safety, food, or vantage points would still offer significant benefits. Let's look at the hands, because they reveal a subtle but meaningful shift. The finger bones are more curved than in modern humans, but straighter than in Australopithecines. This intermediate form aligns beautifully with the archaeological evidence of Oldowan tools. The hand of Homo habilis was capable of the precision grips needed to strike flakes from stone cores. You might think, but aren't stone tools simple? They are, but simple does not mean easy. Even basic flake production requires coordination, force control, and planning. The anatomy of the hand supports this behavioral leap. The skull and teeth also contribute to the locomotion story indirectly. A slightly larger brain and reduced chewing apparatus suggest dietary changes that may have influenced energy expenditure and foraging patterns. A species that scavenges or processes meat with tools can afford to move differently, search differently, and take advantage of new ecological niches. So when we bring all these pieces together, Homo habilis emerges not as a miniature human, but as a transitional navigator, balancing old adaptations with new possibilities. Its anatomy is a record of compromise and innovation, showing us a lineage in motion, both literally and evolutionarily, toward the broader horizons that later hominins would fully explore. Let's revisit the world that Homo habilis inhabited. Around 2.5 million years ago, Eastern Africa was becoming increasingly unpredictable, with shifting rainfall patterns and more open habitats. In that kind of environment, survival depended not just on anatomy, but on behavioral flexibility. And this is where Homo habilis begins to separate itself from the Australopithecines before it. Its behavior hints at a creature responding creatively to environmental challenges, using new strategies that would eventually define the genus Homo. Let's look at the most famous piece of evidence, the Oldowan tools. At first glance, these flakes and cores might seem crude, but they represent a remarkable cognitive shift. To shape a stone deliberately means anticipating how it will break, selecting the right raw material, and applying force with precision. You might wonder why something so simple is so important. Think about what these tools made possible. With a sharp flake, Homo habilis could access meat and marrow from scavenged carcasses, resources rich in calories and nutrients, far beyond what Australopithecines could reliably consume. This dietary expansion likely supported slightly larger brains and more demanding foraging strategies. The archaeological sites associated with Homo habilis show patterns that suggest more than casual tool use. At Oldowan Gorge, for example, concentrations of bones, stones, and flakes indicate repeated activity in specific places. These were not permanent home bases, but they were likely important resource spots, locations where carcasses were processed, materials collected, and food shared. The idea of early central places hints at emerging social behaviors, even if they were limited in scale. Let's look at adaptation in a broader sense. With tools in hand, Homo habilis could navigate food scarcity more effectively. Instead of relying solely on plant foods or opportunistic foraging, it could carve out a new ecological niche, literally. This adaptability also tied into mobility. A species capable of scavenging across a mosaic landscape must track resources, avoid predators, and remember locations. Even without the long legs of Homo erectus, Homo habilis was already behaving like a more exploratory hominin. You might also wonder how social life factored into this. While the fossil record doesn't give us direct evidence of group size or hierarchy, the very act of butchering carcasses suggests coordinated access to sites where multiple individuals likely gathered. Food sharing, even in small amounts, would have reinforced cooperation and reduced the risks of obtaining meat in predator-rich environments. It's not yet the coordinated hunting of later hominins, but it is a step toward greater social complexity. Let's also consider cognitive adaptation. A slightly larger brain doesn't automatically mean higher intelligence, but when paired with tool use, problem-solving, and dietary diversification, it signals that Homo habilis was engaging with its world in new ways. It had to plan forays, navigate unfamiliar terrain, and perhaps even teach or imitate tool-making techniques. Cultural transmission, however modest, may have begun here. So, when we think of Homo habilis, let's think beyond anatomy. Think of a hominin experimenting with new behaviors, reshaping its ecological role, and setting the foundation for everything that follows. This is the beginning of the behavioral trajectory that eventually leads to global exploration, symbolic thought, and the extraordinary adaptability of our species. First, let's revisit what we've seen in this section. Homo habilis sits at a remarkable pivot point in our evolutionary story, still carrying the physical echoes of Australopithecus, yet already stepping into the behavioral and cognitive world that defines the genus Homo. When we piece together its anatomy, locomotion, and use of tools, a compelling picture emerges of a hominin navigating change with creativity and flexibility. Think about this. Homo habilis did not transform overnight into a fully human-like species. Instead, it experimented. It tested new ways of getting food, new ways of moving, and new ways of shaping its environment. You might wonder why this matters. It matters because every evolutionary shift we associate with later humans, bigger brains, broader diets, complex foraging strategies, has its early roots here. Let's look again at how these elements come together. Its mosaic anatomy reflects a lineage still adapting to life both on the ground and at times in the trees. Its stone tools show a willingness to interact with the landscape in ways no earlier hominin had done, and its behavioral flexibility, scavenging, processing carcasses, returning to important resource spots, signals an emerging capacity for planning and cooperation. Now, this part is important. Homo habilis is not significant because it was almost human. It is significant because it represents an evolutionary experiment that opened new possibilities. As we move to Homo erectus, we'll see those possibilities expand dramatically, setting the stage for global dispersal and even more profound transformations. Thank you for joining this lecture. I'm Dr. Richard Jonathan O. Tadurin. I hope this session deepened your understanding of biological anthropology. Keep exploring what it means to be human. See you soon.